At the outset, I will thank my co-authors for their continued support throughout this work. The objective of this presentation is basically the title, like the estimation of urban biogenic greenhouse gas emissions. The motivation of this study is to provide the scientific support for policies which are aiming at net zero carbon communities and net zero carbon emissions. For this, I have taken Ireland as a base study and capital city Dublin. In the following slides, I'll talk about my model setup, how I've improved the urban representation using the local climate zones in WRF model. Then I have included the biogenic urban fluxes at the island scale using the VPR model, and then urbanized the VPRM for the urbanized the VPRM for city scale levels. Firstly, I'll put down the. Uh, Let me tell you about the greenhouse gases in the context of Ireland. Ireland has an objective of climate neutrality of by 2030 and an interim thing of reduction of 51% by 2030. If you see this pie chart here, the dominant emissions are from agriculture, followed by urban, which are represented by transport and residential sectors. The project which I'm working is Terrain AI, which tries to understand the greenhouse gas exchange across various landscape found in Ireland, which are like the forest, croplands, peatlands, and even urban areas. My study region is Dublin, which, as you can see in Ireland, is very small part. So it's and my work is to focus on urban cities. But if you can see, in this context, I cannot isolate urban and rural environments. When we want to work about policies, we cannot just have isolated studies, and that's why I'm providing the model framework across all these landscape with a focus on cities. And the Steering AI includes various observations from satellites, in situ data, flux tower. We have various drones, carbon sniffing drones, and the modeling aspects. Well, the background, it basically reflects the talks from my previous speakers, from Jocelyn or from Dr. Lee and even Mark, that there are various studies which focus on anthropogenic studies, anthropogenic emissions, and the mitigation policies of most of these countries are about reducing these emissions in various sectors. Maybe it is the transport sector, or maybe it's residential sector, or even like in the power plants. But if you pick up the climate action plan of any city, every city across the world, it talks about greening of the cities. But most of the models doesn't have a framework to include this carbon dioxide terrestrial exchange from the vegetation in their models. So we need a comprehensive framework to assess the combined impact of reducing these anthropogenic emissions and greening of studies in becoming the carbon neutral cities. There are very few studies, observation-based studies, one presented by Dr. Lee, and there was one in Singapore which estimates some kind of carbon uptake in an urban neighborhood. We intend to use the modeling techniques to understand the role of vegetation initially on carbon dioxide in an urban landscape. In this presentation, I'm focusing on carbon dioxide, but this model is equally capable of working for the methane emissions, which might not be important for various countries, but in a country like Ireland, which has a lot of peatlands, which can act as a source or sink depending on whether they're dry and wet, it is really important to include them in the conceptual framework. This is a basic model setup for which I have used the WRF with LCZ and greenhouse gas module of the WRF-chem. For this involved, this is a novel work over Ireland, and it included updating various data sets for the model of the study region. I'll just talk about few of them in the slides. What I would say is the parameterization schemes in the WRF model I've used from literature survey, and we have kept in mind to use the scale aware PBL scheme Shinhong because we want to go for higher resolutions. This is my model setup, which is a triple nested domain. The outer domain covers most of the Europe. The middle domain is Ireland at 1 kilometer, and the Dublin city is a 250-meter resolution. I have simulated this model for 3 periods, which was a normal summer period, a normal winter period for Ireland, and a drought and an unusual drought period. The first thing which I have done is improved the urban representation in the model. So the Korean urban class is replaced with the WRF based with the LCZ based LCZ classes using the Woodap to WRF Python tool. And again, it reflects that when we see international scale, there's a very small amount of urban area in the island, and even in the city, we have mostly open high-rise or low-rise cities, and a very small amount of city center which has a compact mid-rise. The anthropogenic emissions right now have taken Edgar V6 Edgar V6, which provides emissions of the three main greenhouse gases. The problem is that this is also at zero point 0.1 degree by zero point 0.1 degree resolution, but it does capture the anthropogenic emissions, namely at the major cities in the island like Dublin, Cork, Limerick, or Belfast, and it also captures the major roadways and the transport ways through ocean. But again, this anthropogenic emission does not include the sources and sinks from land use change, or forestry or vegetation. That is where I include the biogenic CO2 fluxes using the VPRM model by Mahadevan et al., which calculates the net equation NEE, which is the sum of GE and respiration. And this equation depends on three parameters of temperature, of water, and the leaf age of canopy photosynthesis. I've used the VPRM preprocessor which generates the vegetation fraction, Modis-based LSWI and EVI, and I'm showing an example for the major vegetation class, which is the grasslands across the inner domain. This is the scale is 0 to 1 for vegetation fraction and EVI, and minus 1 to 1 for LSWI. The VPN parameter I've used currently if in this work is the default table given by the VPRM. But now we have some NEE fluxes from the terrain AI data set at few of the cropland or forest sites, and we know we have some kind of Hilton et al. Had published that we can estimate these parameters using the eddy covariance method, which I'll be using it. The one thing to notice here is the VPRM only works for the vegetation classes. The urban is included with others, the others being snow, water, or barren lands. So what does VPRM do? If we don't include biogenic emissions, we get a blank scale, a zero. There is no effect of vegetation on the CO2 fluxes. When we include VPRM, we see a sequestration during daytime, which is directly attributed to the photosynthesis, and there is a small amount of respiration during night time. This I have taken few sites, a few vegetation sites and a peatland site in the island, and we see that there is a good amount of sequestration throughout the day, while a small amount of respiration increase at the night. And when you see it in the vertical, the influence of this vegetation is basically located basically around the boundary layer height. It is subdued during night time, but then it increases to the residual layer and mixed layer during the daytime. Before going further, I did some of the model performance evaluation. I have done model performance evaluation for various stations across Ireland, but I'll show you for one of the urban station, which is the Dublin Airport station. And the meteorological evaluation I have done for temperature, for wind, and precipitation. These three were important for the photosynthesis, for the dispersion of CO2, and for the leaf stress. And we see there is a good improvement of the model prediction after using LCZs. Then I have done a basic comparison of CO2 fluxes at three available sites at the edge of the country, and we see we do fairly well in estimating the trends of CO2. There is slight underestimation of 2 to 5 ppm at various sites, but this could be attributed to the resolution of the input emissions and the boundary conditions. Next, what I have done is what I have urbanized the VPRM. Uh, so I mentioned that urban was included in the others category. So what I have done is I had subdivided this others category to urban and non-urban, non-vegetated areas. And following Hardiman et al., right now we could only give one dominant category and have use the values of deciduous forest, which is the prominent tree species in Dublin. And then The original equation of GE in the model equations, which only work for the 7 categories, I have extended it to 8 categories with the consideration that the various scales would be activated only for urban categories and remain zero for the other NU/NB categories. Then the urban fraction is taken from the LCG classification is taken as a proxy for the green cover, and following this, the equation in the urban areas are updated. So when we use this urban model, urban BPRM and the original BPRM, again, as I say, when we see in the national scale, we don't see much differences, which is acceptable. But if when we see the difference between the urbanized BPRM and the original BPRM for a typical daytime, we see we see the impact of urbanizing, the sequestration of CO2 even in the urban areas, which are like in some of the dominant cities like Dublin and Belfast and Cork, and I've shown a zoomed version for Dublin. And again, again because it's a dynamic model, it's not a standalone model. The advection also plays part in distributing this biogenic fluxes in the urban areas. And similarly, we see a respiration, a very small amount of respiration during the night time. So, what does it do? So, so if we see this kind of what is the impact of this urban biogenic CO2? Does this tree do anything? I just plotted the vertical profiles, and I saw that the influence is again, as I said, is up to the boundary layer. In this case, it was up to 800 meters. And if we integrate this volume over the city, I have taken a small blue box over the city, 7 by 11 kilometer. If we integrate this volume, we see there is a considerable, there is the difference in the VPRM, and it shows the influence, the impact, the role of urban trees in sequestering the CO2, and the maximum of about 1.4 ppm is seen, which is roughly around 24 tons of CO2 sequestered per day. Again, as I said, I'm going to work for 250-meter resolution. I validated meteorology at 2 of the stations available, but the work is in progress for the biogenic fluxes. For my conclusions, I have done the high resolution WRF-chem setup with updated data sets on island scale. I've improved the water simulated meteorology using LCS and the inclusion of VPRM. The implication of my work is to urbanize this VPRM biogenic emissions, not just the dominant category, but we might use a mosaic approach to have more inclusive form of the urban vegetation. Going for updated met iron data, which is available at 1 kilometer resolution. And then finally, that this is what WRF can do. This is where WRF stops. So we have to go to multi-scale modeling. If we have to work with street scale modeling or a neighborhood scale modeling, we have to go from mesoscale models to urban grid models. Thank you. These are some important references.
Thank you. That was very interesting. We've got questions from the audience.
So if I understood correctly, you are now considering only trees and not, for example, lawns.
Right now, just trees. Yes, the deciduous trees.
Because what we have found that if we compare, for example, a boreal forest and an urban lawn in Helsinki, the urban lawn on an annual level uptakes out roughly half of the what the forest is uptaking per square meter. So if you have wide areas of lawns, that can even multiply the amount of photosynthesis taking place in the city.
Thank you. That is what I said. That right now we have the option of just giving the dominant category, but I want to have the mosaic approach of having maybe shrublands and lawns and the actual representation of the vegetation around the city.
Thank you. I think we're going to move on to. Can I just check before we start? Have we received that last presentation? No. Okay. So this is going to be the last presentation.